Okay, this is a review for Chapter 7 for Algebra 2 CP. Chapter 7 is probably one of the more complicated sections, only because it's kind of foreign. It's a little bit different than stuff that you've done in the past, and it doesn't really relate to Algebra 1. It's kind of brand new. So for that reason, it's kind of more difficult. But with a little bit of help and a little bit of review, I think that should be pretty doable if you take the time and effort. So the first thing I want to talk about is how to graph an exponential equation, okay? And my tip to you is simply just use your calculator. So what I mean by that is type it into your calculator, and then I'm going to look at my table. I'm not really even going to look at the graph, okay? I think we get into trouble when we look at the graph because you'll see a graph and then you'll just kind of draw what you see. Don't do that. Use the table, plot points, and understand something about this equation. So looking at this one, I'm going to type 1/2 to the x minus 1 power. And I really recommend putting that power in parentheses, no matter what kind of calculator you have. If your calculator looks like this, when you type exponents, still put it in parentheses. It's a good habit to have. So I'm going to type that. I'm not even going to graph it. I'm just going to look at my table, and I'm going to see some points, okay? So what you see here is -2, 5, -1, 1, 0, -1. And you see that the values never fall below -3. And that's because this is a horizontal asymptote. So the graph never crosses, never goes below y equals -3. Okay, that's what we call a horizontal asymptote. All right, so if you hear that word horizontal asymptote, vertical asymptote, y equals -3 is a horizontal asymptote. And if you're one of my students, then I don't want to see any points go below that line. So what I'm going to have you do is draw an imaginary line. That's your horizontal asymptote at y equals -3. And you know that looking at the table, no points will ever go across that. So when I graph this, just make sure that your graph follows that line, never crosses that line. So the other thing I'm going to do, I'm going to find some points. So I got -1, 1, 0, -1. All right. 1, -2, 2, -2.5. All right, so I plot these points. So I got -1, 1, 0, -1, 1, -2, and 2, -2.5. Okay, so you see the shape of the graph, and if you're like, oh, Mr. McLean, whatever, I want to see what the graph looks like. I want to hit graph. Feel free. You'll get an idea what the shape is, but please, please, please don't just graph from that, okay? Because clearly you're going to make a mistake. You're going to cross a line that you shouldn't cross. But I'm going to be very careful. I'm not going to cross the horizontal asymptote, and my graph's going to look something like that. So after I've done that, I've graphed it. I successfully graphed it. I plotted my points. I made sure it didn't cross the line y equals -3, and now I got to find the domain and range. The domain has two restrictions, okay? If x is on the bottom of a fraction in the denominator of a fraction, you might have a restriction in your domain, or if x is under a radical, you might have a restriction in your domain. X is not under a radical or on the denominator of a fraction. So this one is all reals. Okay? Y values, on the other hand, have to, like we said, be above the line y equals -3. So if I graph like on the y-axis, this is how I determine range. I kind of look at the y-axis and I say, like, my graph starts at -3 and goes up. Okay? So if I was graphing an inequality, like y would be greater than -3. Not greater than or equal to, but greater than, because it doesn't include -3. It doesn't ever touch -3. So that would be my domain and range for that particular question. All right, moving on. We get into the solving questions. Okay, this is where you need your logs. So when I solve a question, I have to determine where the variable is at, and that's going to give you a clear indication of what you want to do. So for this first one we're looking at, I'm going to solve for x. The variable is in the exponent. Okay, when it's there, I'm going to do something specific, but before we even get to that specific thing, I got to get that 4 to the x by itself. So these steps involved, I'm going to get 768 divided by 3. 4 to the x equals 768 divided by 3. Let's see what that comes out to. It's going to be 256. And at this point, I'm ready to do to get the 4 to the x on one side and then ln both sides, okay? And this should be 4 to the x, not just 4x. Okay? And then ln both sides. So at this point, it's like anything. Like if I see x squared equals 25. Well, you want to find x, you got to do something to both sides. Well, I do the opposite of squaring, which is square rooting, okay? If I see 2x equals 10, I want to do something to both sides. To solve that, I divide, because x times 2 makes 10. I'm going to divide both sides by 2. So you see, it's the same concept where you're going to do something to both sides. That something is to take the ln. So I'm going to take the ln of both sides. And in doing so, outline that in black so that you can. In doing so, I'm going to be able to solve this equation because the property of exponent says I can pull that x in front. And now my equation should look like x ln 4 equals the ln of 256. So you see how taking the ln of both sides is just like the operation that you perform, just like we were saying before. Like if you have whatever equation, you always end up doing something to both sides. So in this case, if you have an x in the power, you ln both sides. So I'm going to divide both sides by ln. And here in your calculator, you just go to your calculator and say ln of 256, and ln is right next to the 4, divided by the ln of 4, and you're going to get your answer. In this case is 4. And that makes sense, okay, because 4 to the 4th makes 256. So x equals 4. And you could check it, plug it back in, right? 3 times 4 to the 4 plus 5. Does that equal 773? Does 3 times 4 to the 4th power plus 5 make 773? And it does, so you know you did it right. So it's really easy to check. It's an equation, just like any other equation. Check it by plugging it back in. All right, next one. Log base 5 of x equals 3. So I'm looking at that and I'm saying, okay, where's my variable? Well, I got a log on one side. So when I solve it, I'm going to change it. If I have a log on one side, I'm going to change it back to an exponential equation. So when I do that, base 5 to the 3rd power equals x. And if you know how to change a log to an exponent, problems like this shouldn't be very difficult. It doesn't matter, where the x is really. If there's a log on one side, a number on the other, change it back to an exponent. So now I see 5 to the 3rd is 125. So my answer very simply is 125 for x. Okay? Once again, determining where the variable is at, determining what the equation looks like. Okay, and then differentiate between this one and this one. Well, I don't have any logs. I got an exponent with an x in it. So I'm going to ln on both sides. I have a log on one side, and compare that to this one where you got logs on both sides. You got 2 logs on one side. So here's where I want to condense, okay, and then solve. This one's a little bit more complex. So when I condense, a minus between 2 ln's means I'm going to divide the 2 things inside the ln's to get it back into 1 ln. So it's going to be x divided by x minus 2 equals the ln of 8. And at this point, you're like, well, I got ln of x over x minus 2 equals ln of 8. Well, that should be pretty easy because this should just equal that. If they're both inside the ln, that's how I'm going to solve it. So x over x minus 2 equals 8. Multiply both sides by x minus 2 to get rid of it down here. I get that x equals 8x minus 16. All right. I'm going to subtract 8x. I get negative 7x equals negative 16. Divide both sides by negative 7. I get 16 sevenths. Okay, so not the prettiest answer, but the solving of it shouldn't be too crazy. You condense, set both sides equal. Again, what does it look like? Are there ln's on one side or are there ln's on both sides? Okay, in this case, if they're on both sides, it's even easier. You just set the parts inside equal to each other. All right, so it's going to take some practice, but if you do your work, I think that you'll find that this stuff isn't impossible. It's just kind of a different kind of thing that you maybe are not as familiar with. So moving on, there's a few other questions I wanted to talk about, expanding and condensing being one of them. We kind of did expanding and condensing when we solved, but just to kind of recap it. When I expand, I start with 1 log and I end with many logs. When I condense, I start with many logs and end with 1. All right. When I expand, I go quotient, product, power. Okay, so when I see quotient, I'm looking for numbers divided inside. When I see product, I'm talking about numbers multiplied, and power are numbers that have exponents. Condensing, I'm going to go the opposite direction. Okay, so just to kind of recap this shouldn't be completely foreign. I don't have any quotients, and when I'm talking about quotients, I'm looking right here. Do I have anything divided? No. Do I have stuff multiplied? Yeah. When I have stuff multiplied, I can split that stuff up by adding between 2 ln's. Okay, so that's giving me ln of x plus the ln of y squared. Okay, I can pull that power out front. I've taken care of the product rule, And again, after I've taken care of the product rule, I ask myself, do I have any more products? Do I have any more quotients? No, in both of those. So at that point, all I have left to do is take the power, which is y to the second, and pull that out front. So my final answer is ln of x plus 2 ln of y. All right. The second one is condensing, so I'm going to go the other direction. So when I ask myself, are there any powers? I start with that. Are there any powers? Well, yeah, if the numbers out front, these used to be powers. So I'm going to take those first. So it's going to be log base 3 of r minus log base 3 of 2 to the 5th plus log base 3 of m to the second. All right, here's where you say, okay, do I have any products? And in this case, yes, you see that you do have products because you got a plus between these two. So you got to make sure you do product before quotient in this particular case. So at this point, I could take log, well, I shouldn't say product before quotient. Let's see what happens if, yeah, so I'm going to take product before quotient. But sometimes you can have minus. In that case, you got to take into account a little bit something different, which we could talk about. You could ask your teacher about it. Meaning, if this sign right here were minus, then you'd have to do a little something different. But I'm getting outside of this question. I'm going to do products first. So if you see plus between, right, you bring those things together with multiplication. So it's going to be 2 to the 5th, which is 32. So again, I'm just changing 2 to the 5th and setting it equal to 32. And it's going to be m to the second. At this point, you got one more thing to do. You got a quotient. It's log base 3 of r over 32m squared. So there's my final answer. Once again, if you're condensing, you start with many logs and you end with one. Don't like end with multiple logs. If you know you're supposed to condense, you're supposed to end with one thing. So hopefully that helps you to expand and condense a little bit better. All right, and then the last question I want to talk about is exponential growth and decay as it kind of refers to money. So compound interest can be done in two ways. You got two formulas. You got A equals P times 1 plus R over N to the NT. And then continuously, which is A equals PE to the RT. Okay, if the problem says each year, then you're going to take the first formula, but N is going to be 1. That's actually very simple. So it says you buy a new car for the price of $10,700. The salesman says that each year the car will depreciate by about 15%. Okay, I chose this one because your rate is actually negative. When you talk about percents, you talk about, well, 15% is 0.15. So in any case, I know I'm going to use this problem. Okay, it doesn't say continuously anywhere in this problem. So, and it says each year. So basically I'm going to use this equation. And I know N is going to be 1 because it's each time per year. So the tricky part here is I know that the value of the car to begin with, P, is 10,700. Okay. And I know that the rate is 0.15. However, it's not 0.15, it's negative 0.15. And that's going to be kind of key because if you're decreasing the amount of money it's worth, you're going to your rate has got to be negative. Okay, it's just simply the way it's got to be. All right. And then T is obviously the amount of time, and A is going to be the time is going to be your ending amount, $500. So in this particular setup, A is going to be, I want to find out when it's going to be $500. So it started at 10,700. N is 1. The rate is negative 0.15. And I'm just going to solve it. N again is 1, so I'm just going to leave that 1 times T. And I'm going to solve for T. So at this point, I have to figure it out. Where's my variable? How do I solve? So I'm going to divide by 10,700. I get 500 divided by 10,700. Gives me 0.047, we'll say. And then 1 minus 0.15 is 0.85 t. Okay? So at this point, you ask yourself, well, where's the variable? The variable's in the power. So that means I'm going to do ln of both sides. So I'm going to take the ln of both sides. That's going to allow me to pull the t out front. So it's going to give me, bring it over here, it's going to give me the ln of 0.047 equals t times the ln of 0.85. So I'm going to divide by ln of 0.85. I should get t. So it's going to be the ln of that answer I just got. So I'm just going to grab it. It's going to make it a little easier. Divided by the ln, and don't forget to type ln. You got to type it twice. The ln of 0.85. So the question is, when will it be worth $500? After about 18.85 years. So that would be your answer there. Okay. Hopefully this helps you. Once again, where is the variable? That is huge. Okay, so if you determine that the variable is in the exponent, then you do LN both sides, just like we talked about, right? So practice, 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 and you should be good at this stuff after some time.